This activity is entitled Verifying the Property, which involves both HCF and LCM. The objective of this activity is to verify the mathematical property that connects the HCF and the LCM of two numbers, and the property states as follows. HCF times LCM, that is the product of HCF and LCM of numbers, is equal to the product of the numbers themselves. Let's understand the concept behind this activity. If we have two numbers like 12 and 15, we know that the highest common factor of 12 and 15 is 3 because they go into 3, and LCM, that is lowest common multiple of 12 and 15, is 60 because that is the smallest multiple which is divisible by both 12 and 15. Now, if you multiply the LCM and the HCF, you get 60 times 3, which comes out to be 180. And if you see the product of the numbers which are taken up, the numbers were 12 and 15. When you multiply them, you obtain the same result, that is 180. Therefore, we have the property that LCM times HCF of any two numbers is always equal to the product of numbers. To perform this activity, we require the following material. We require 8 cards, each with one prime number from 2, 3, 5, 7. So you can repeat the cards with the same number. You require chart paper. You require colored pens or pencils. Then we require some factor tree templates with 5 at the end. So when we make factors of a particular number, the number you obtain at the end, we have taken it as 5 just to simplify the activity for the students. So let's see how this activity can be performed. To perform this activity on verification of the property of HCF and LCM, that HCF and LCM is actually equal to the product of numbers. The product of HCF and LCM will always be obtained when you multiply the two numbers. We have this observation table, and to write which numbers we are using, we will draw these factor trees, and we will be using these factor trees to find out the numbers whose HCF and LCM will be found out. So as you can see here, in both the factor trees, I have taken a 5 at the base. Here also we have a 5 at the base. So let's use the first factor tree first. And to select what divisors A, B, C, D we are choosing, we have these cards, and you can see the numbers are very simple. These are the prime factors, so we have prime numbers written on them. 2, 3, 5, 7. These are the numbers which I have written, and I have a lot of these circular cards which I will place face down on the table, and I'll have to draw one factor from this. So what are we going to do is, like suppose if I draw out a factor of 5. So I'll paste the 5 here, and because 5 times 5 is 25, I will write 25 on a piece of paper and then cut out a circular card from that and paste it on P here. So this part will become 25. And likewise, I have to choose another factor now. Suppose the factor comes out to be 5 again. So I will paste this factor 5 here, and now because 25 times 5 is 125, so I will make another card on which I will write 125 and cut it out exactly in this shape and paste it here. So this entire thing will become 125. Likewise, I have to keep drawing some of the factors from these various factors which I have written on the circular cards. Let's say this one. So I have a 2. So I will place the 2 here. Now 125 times 2 is 250. So this part will be overlapped with a card showing 250. And finally I need one more. So I will take out one more card. So this comes out to be 5 again. So 250 times 5, this particular number will be 1250. So the first number which I have obtained is 1250. How do I fill the observation table? Let's write serial number 1. The first number is 1250. The prime factorization is 52555. So how many 2's I have? 2 raised to power 1, and times how many 5's I have? 1, 2, 3, 4. So 5 raised to power 4, and that becomes my prime factorization of 1250. Likewise, I have to take the other factor tree now, and I will do the similar thing with this factor tree. So how do I do it? I will again start with a 5 here, pick up some random cards. Like if I pick up a 2, then I'll paste the 2 here. So this gives me 5 2's are 10. So this will be pasted with a card showing 10. Likewise, keep on drawing out some cards. Like if I draw a 7, I'll place a 7 here. So 10 times 7, this part will become 70. And then if I take out one more card, say this is 3. So this 70 into 3, this part will become 210. And finally one more. So if I pick out a 2, then 210 times 2 will be 420. And this part will give me the second number 420. So I'll have to record it here 420 and write all the factors which I have obtained. How many 2's? There are 2 2's like this. How many 3's? There is only 1 3. How many 5's? I have only 1 5. And how many 7's? I have 1 7. So I have to write the exponential form of the factors like this. Now to find the HCF, I'll take only the common factors. So there is 1 2 which is common and 1 5 which is common. So 2 into 5, 10 becomes the highest common factor. Now to find the LCM, I have to take the higher power of the common factors. So 2 power 1, 2 power 2 means 2 power 2. 5 power 4, 5 power 1 means 5 power 4. And then we have the uncommon factors 3 and 7. So once I do the multiplication of this will be 4 times 5 raised to power 4 is 625 and times 21. This will give me 1250, so 2500 times 21, that gives me 00, and then 25 into 21, which is 525. So the LCM of these numbers, these two numbers 1250 and 420, comes out to be 52500. Now when I multiply the HCF and the LCM, the product of these two numbers will be 52500, and the product of the numbers 1250 and 420, that will again come out to be the same number 52500. And yes, the property is verified that the product of HCF and LCM is actually equal to the product of numbers, thereby giving you the same number in these two columns. Now the students can repeat this using a second trial, using a different factor tree, maybe having 3 branches or more branches, so that they can take higher numbers also. And that completes our activity on verification of property of HCF and LCM of numbers.